Hi, now this is the first question in heat conduction. Find the amount of heat that will flow in an hour through an aluminum rod 6 cm in diameter and 1.7 meter long. If one end of the rod is maintained at a temperature of 120 degrees Celsius and the other end at 30 degrees Celsius, okay, the thermal conductivity of aluminum is 240. Okay, so the question asks for the amount of heat. That means he asks for the Q. Okay. Time taken is 1 hour. This is the time taken. This is an aluminum rod, and 6 cm is the diameter. We have the length of the rod, 1.7 meter. This is the length. Okay, and then he gives us the temperature, a hot end and a cold end. And the thermal conductivity of aluminum, this is K. Okay, K, 240. So yeah, I summarize the information down here. So the time taken is 1 hour. So we must convert to SI unit. Okay, second. So 1 hour is 60 minutes times 60 seconds. We have 3,600 seconds. And then the diameter, give us diameter is in cm. So remember to change to SI unit, meter. Okay, divide by 100. Remember, if it is a rod, okay, since this is a rod, see that? This is a rod. So, and then it give us diameter. This is a give us diameter. So this one must relate to a circle. This one relate to a circle area. So whenever he give us a diameter, we straight away find the area. Okay, we straight away find the area. So area comes with formula pi r square. Pi r square also pi diameter square over 4. Because radius is diameter divided by 2. So we get pi diameter square over 4. So let's calculate out what's the diameter. What is the area? So we got the area when we substitute 0.06 into the diameter, 0.06. And we get the area equal to 2.8274 exponent negative 3 in meter square, because we already changed to meter. Okay, so that's our area. Remember, whenever it gives us diameter, we can straight away find the area. And give us the length. Okay, give us the length and the thermal conductivity. Okay, so this one relate to heat conduction. Yeah, thermal conductivity of aluminium. So and then give us the temperature of both ends. One is a hot one and the other one is a cold one. So which one should be the initial temperature? Is it the hot one initial or the cold one as initial? Which one? So you look at this diagram. The heat always flow from hot end to cold end. Heat always flow from hot end to cold end. Never the heat flow from cold to hot end. It always is the heat that we call the net heat flow. The net heat flow always from the hot end to the cold end. So the initial temperature should be the hot temperature, the high temperature. Okay, the heat always flow from high temperature to low temperature. So the hot end is the initial temperature, the cold end is the final temperature. So 120 degree is the initial temperature because it is hot, and 30 degrees Celsius is the final temperature because it is cold. Okay, remember the sequence. Don't invert. So okay, we have the temperature already. Now we just apply the formula of rate of heat flow. Okay, the rate of heat flow dq over dt is equal to negative Ka dt over dx. So what the question want is to find the Q only. Okay, Q. The time already given. So he want us to find the only the Q. Maybe I just change the like. Yeah, he want to find the Q only. the time taken already given, yeah, 1 hour. And then the change of temperature is final temperature, yeah, final temperature minus initial temperature. Yeah, change of temperature is always final minus initial temperature. The final, because heat always flow from hot to cold. Okay, heat always flow begins with the hot. Yeah, heat always flow from hot to cold. So the cold temperature is the final temperature. Okay, the hot temperature is the initial temperature. So final temperature minus initial temperature is cold temperature minus hot temperature. Okay, remember. And the unit given is degrees Celsius. No need to change to Kelvin. Yeah, because we are talking about change of temperature. Still remember? In the summary, I did mention that when it is about the change of temperature, you can either, yeah, the change of temperature. When it's about the change of temperature, you no need to change to Kelvin. Yeah, you can maintain as degrees Celsius or Kelvin, because the change of temperature of 1 degree Celsius is equivalent to the change of temperature 1 Kelvin. When the temperature increase 1 degree Celsius, it also increase 1 Kelvin. They are equivalent. Okay, so you can maintain as degrees Celsius. No need to change to Kelvin. So now let's substitute all the information we have. Okay, so ask us to find the Q, and then you want the change of the time taken is 3600 seconds, and then the thermal conductivity is 240. Area we got just now 2.8274 exponent -3, and then change of temperature is always the cold. Cold is the final temperature. Yeah, heat always flow from hot to cold. So cold temperature is 30 degrees Celsius, and the hot temperature is 120. So final cold minus initial hot. So you can still maintain as degrees Celsius. Okay. Sorry, I think I should write. Yeah, clarify the unit. Okay, so 30 degree you can maintain as degrees Celsius because it's change of temperature. You can change of temperature can use either degree Celsius or Kelvin, both accepted. Yeah, because 1 degree Celsius is equivalent to the change of 1 Kelvin. Okay, so you can maintain as degrees Celsius, and the length of the rod is the distance traveled by the heat. The length of the rod is the x. Okay, 1.7 meter. So just put in 1.7 meter, and then you can calculate the Q. Okay, you can calculate the Q, and what you see. This one you get surely you get a negative value, isn't it? 30 cold low temperature minus a high temperature, surely you get a negative. Surely you get a negative value. So when negative multiplied by a negative here, negative multiplied by negative, the heat always get a positive value. Heat always get a positive value. So heat is equal to 1.29 exponent 5 joule. Okay, heat always you get positive value. If you get heat equal to negative value, means maybe here you use 120 minus 30. Then you get a positive value. When positive multiply a negative, you get negative heat, which is wrong. So remember, always use a cold minus the hot temperature in order to get a negative value here. So when negative multiply negative, you get a positive heat. So remember, heat always positive. Don't ever get a negative heat. Yeah, heat is heat energy has always positive value. Okay, remember? Yeah, why cold minus hot? Because it is again, just want to emphasize that it is the final minus initial. Because it's final minus initial, and initial is always hot. Because why? Heat always flow from hot to cold. Heat always flow from hot to cold. So 120 should be the initial temperature because it is hot, and 30 degrees should be the final temperature because it is cold. Okay, so cold minus hot become 30 minus 120. So that's all for these questions. I hope you are clear with what temperature minus what temperature. And finally, the heat, you must get a positive value. Okay, whenever give you diameter, you can change to area. Okay, that's it for these questions. So stay tuned for the second one.